In this lesson, we're going to go over how to simplify complex fractions, and this is going to involve adding, subtracting, multiplying, and dividing. So what exactly is a complex fraction? Well, a complex fraction is basically a fraction within a fraction. So if we look at this example that we have here, we have 1/4 over 5/6. So we have a fraction on the top and a fraction on the bottom. And this line here is our division bar. So we can rewrite this entire complex fraction as a regular division problem. So we can make this 1/4 divided by 5/6. And we know that when we're dividing fractions, we can stay switch flip and turn this into multiplication. So this would become 1/4 times 6/5. And then from here, we want to see if we can reduce or cancel out any common factors that are on different levels. So looking here, the 4 and the 6 are on different levels. They're both divisible by 2. So I can divide the 4 by a 2 and get 2, divide the 6 by a 2 and get 3. So now I have 1 times 3 on the top and 2 times 5 on the bottom. So I end up with 3/10. So this same idea we can use when simplifying rational functions. So here we want to simplify and determine the domain restrictions. So just like our example before, we have a fraction on the top and a fraction on the bottom. And this line here is our division line. So we're just going to set this up as division. So we have 3x over x minus y divided by 6xy over 4x squared minus 4y squared. Because we have this division problem, we can stay switch flip. So 3x over x minus y times 4x squared minus 4y squared over 6xy. Once it's set up as a multiplication problem, we can then go ahead and factor everything that we can. So I'm going to keep the 3x and the x minus y because they can't be factored. The 4x squared minus 4y squared, I can pull out a common factor of 4, and I have x squared minus y squared. But the x squared minus y squared is difference of squares, so I can factor that a little bit more. So what I'm going to do is just get rid of that and factor that piece. So that would become x plus y and x minus y. And then 6xy, we can't do anything with that, so we'll leave it there. Okay, now we want to see if we can cancel out any common factors. So we have an x minus y and an x minus y. We can cancel out this x with this x. And the 3 and the 6, I can divide both of them by 3. So this will be a 1, and this 6 will become a 2. So now when I look at the numerator, I have 1 times 4x plus y. So I just have 4x plus y. And then in the denominator, I have 2y. Oops, and I didn't even realize I could divide that. So I'm going to go from here, the 4 and the 2. I can divide both of those by 2. So that goes away and becomes 1, and this 4 becomes a 2. So I could have done it, or I should have done it, I guess, in this step, but I didn't notice it. But that's okay. If we don't notice it, we can always simplify more as we go. So we get 2 over x plus y over y. And that would be our simplified answer. And then we also want to find our domain restrictions. So we're going to set everything that was ever once in a denominator equal to 0. So we're going to set the denominator of the first fraction to 0. So we'll say x cannot equal y. We're going to set the numerator of the second fraction equal to 0. So the 4 on the outside is a constant, and we can't set that to 0, so we ignore that. X plus y, we set that to 0, and we get negative y. X minus y, we set it to 0, and we get y, which we already had. And then the 6xy in the bottom, we set that to 0, and we get 0. But because we have this y also in the bottom, we also have to say that y cannot equal 0. So x can't be y, negative y, or 0, and y can also not be 0. And those are all of our restrictions. Okay, so let's look at another example real quick. Okay, so same idea here. We're going to have x squared minus 9 over 6x minus 12 divided by x squared plus 10x plus 21 divided by x squared minus x minus 2. So from here, we're going to stay switch flip, and I'm actually just going to combine a couple of steps. So I'm going to factor and stay switch flip at the same time. So I'm going to get x plus 3, x minus 3. I'm using difference of squares for that x squared minus 9. 6x minus 12, I'm going to pull out a GCF of 6. So I have x minus 2. I'm going to change that to multiplication, and I'm going to flip this. So here we're going to flip those, but I'm also going to just factor in this step. So my numerator will now be x squared minus x minus 2. And if I factor that, I'm going to get x minus 2, x plus 1. And then my denominator will now be x squared plus 10x plus 21, which would be x plus 7 and x plus 3. So once I have everything factored out, I can go ahead and try to cancel things out. So I can get rid of this x plus 3. I can also get rid of this x minus 2. So what I'm left with is an x minus 3 and an x plus 1. And in the denominator, I have a 6 and an x plus 7. Okay, and that's fully factored. And again, I also need my domain restrictions. So I'm going to take the denominator of the first fraction and set it to 0. So x cannot equal 2. I'm ignoring that 6 because it's a constant. I'm going to take the numerator of the second fraction, set it to 0. So x minus 2, we already have 2. X plus 1, we'll get negative 1. And then the denominator of that second fraction as well. So we'll get negative 7 and negative 3. And those are our restrictions. Now, what if there's addition or subtraction involved in one or more of the fractions? Well, in that case, we're going to be able to use two different methods. And it's really up to you which of these two methods you want to use. I typically will use method 2, and I kind of suggest using method 2. I believe in pre-calculus, they also use method 2, so I would definitely go for that. Method 1 is just to help you kind of understand why we're doing what we're doing. So we're going to do both methods on the same problem. Basically, method 1 involves splitting this up into the top and the bottom. So you're going to isolate the top fraction and get a common denominator and simplify it. You're going to do the same thing with the bottom fraction and simplify it. And your goal is to get one fraction on the top and one fraction on the bottom. And then once you have that, we're just going to do what we've done before. We're going to have that division that we're going to stay switch flip and change to multiplication. Method 2 involves getting a common denominator for every single denominator that we have, and then multiplying the top and bottom by that common denominator, and then getting rid of them. And then again, stay switch flip and make it into multiplication. So let's actually look at these methods so we can see what they're all about. So in method 1, what we're going to do is we're going to focus on the top and bottom separately. So we're just going to look at the top. So I'm going to rewrite 1 plus 2 over x as 1 over 1 plus 2 over x. And then the denominator, I'll actually change colors for that. This is going to be 2 over 1 plus 3 over 2x. Okay, so all I did right now is I made the whole numbers have a denominator of 1 just to set it up as a fraction. Okay, so I'm looking only right now at the numerator. So I'm looking at the denominators. I have a denominator of 1 and x. So my common denominator here would have to be x. So that means that I need, make this a little bit smaller, I need an x here and here. Okay, so we have, I'll just change that as also. So this is going to give us x over x plus 2 over x. Because I have that common denominator of x now, I'm going to add the numerators. So I get x plus 2 over x. So that's my new numerator. So what I did here was I took 1 plus 2 over x and I combined it and made it into one fraction of x plus 2 over x. So I'm going to do the same thing for the denominator now. So in the denominator, 2 over 1 plus 3 over 2x. So my denominators are 1 and 2x. So I need to multiply this first one by 2x on the top and the bottom. So I will multiply 2x times 2. So that's going to give me 4x over 2x plus 3 over 2x. Because I have that common denominator, I can now add the numerators together. So 4x plus 3 over 2x. And now I have one fraction over one fraction. And that's the kind of the goal that we want to have. And then once we have that, we're just going to set it up as a division problem. So divided by 4x plus 3 over 2x. Okay, then we're going to stay switch flip it. So that's going to become x plus 2 over x times 2x over 4x plus 3. And then we can cancel out this x and this x. So now we're left with 2x plus 2 over 4x plus 3. Nothing else can cancel out, so that is our final answer. And then for our restrictions, we're going to go back to the step before we simplified, and we're going to set all of our denominators to 0. So we have 0 for here because we have just an x. Set the numerator of the second fraction because we flipped it. So again, that's 0. And the denominator of the second fraction, which would be negative 3 over 4. So those are our restrictions. So this method has, I guess, a few more steps. It's maybe a little bit more work to do, but if you're kind of confused as to what we're doing, we're basically just splitting the top and the bottom. So if you can understand that, then use method 1 if this makes more sense to you. Method 2 is the same type of idea, but we're going to do it in less steps. So for method 2, we're going to look at all of our denominators. So on this 1, our denominator is 1. This 2 over x, we have x. This 2 over 1, we have 1. And this 3 over 2x, we have 2x. So out of all 4 of those denominators, so I'm just going to write it here real quick. We have a 1, we have a 1, we have an x, and we have a 2x. So what can I make all of these become? So I can make all of them a 2x. So my lowest common denominator, my LCD, is going to be 2x. I'm just going to get rid of this so we don't get confused. So my LCD is 2x. So what that means is that I'm going to multiply everything by 2x. So I'm going to do 2x to the top and 2x to the bottom. So when I multiply by 2x over 2x, I'm really just multiplying by 1. So I'm not changing this problem at all. I'm just multiplying it by 1. So for just showing you the first time, I'm going to write this out more than I normally would. And the next problem after this, I'll do it a little bit, I guess, quicker. But basically, this 2x in the top is getting multiplied to both of these. And the 2x in the bottom, same thing, is getting multiplied to both of these. So what I really have here is going to be 1 times 2x plus 2 over x times 2x over 2 times 2x plus 3 over 2x, times 2x. Okay, so like I said, I'm normally not going to write it out like this. I just want to show you where I'm getting these things from. So I'm taking the 2x and I'm multiplying it to both terms on the top and both terms on the bottom. When I go ahead and do this, 1 times 2x is going to give me 2x. 2 over x times 2x, well, this x and this x will cancel out. So this is just going to be 4. In the bottom, 2 times 2x, that's going to give me 4x. 3 over 2x times 2x, the 2x's are going to cancel out, and this is going to give me 3. So then again, I just want to make sure that I factor the numerator to see if anything can cancel. So if I pull out a GCF of 2, I have x plus 2 over 4x plus 3. And here's my answer, which is the same as the answer I got for method 1. But you can see that there's a little bit less steps involved. And typically, I won't necessarily write this out here. I'll just kind of go ahead and cancel out the things that cancel out. So once you get comfortable with this method, if you choose to use this method, you'll see that it's actually a little bit faster than this as well. And our restrictions are just going to be the same as from method 1. But when I find my restrictions, what I'm basically going to be using is I'm going to be using my LCD. I'm going to set my LCD equal to 0. So 2x, set it to 0, I get 0. And then the denominator of my answer, I'm going to set it to 0, and I get negative 3/4. So we get the same exact answers as we got before, but we're kind of doing it a different way. So in method 1, our domain restrictions are coming from anything that was once a denominator in our problem. In method 2, our domain restrictions are coming from the lowest common denominator and the denominator in our answer. Okay, so you can choose whichever method you like. If you like method 1 better, use method 1. If you like method 2 better, use method 2. In the next 2 examples that I'm going to go over, I will be using method 2. But if method 1 makes more sense, please use method 1. So for this problem, okay, we're going to look at all of our denominators. So I have x plus 4, I have 1, and I have x plus 4. So my LCD is going to be x plus 4. So what I'm going to do is multiply x plus 4 over x plus 4. So the x plus 4, I'm going to multiply to both terms. So 2 over x plus 4 times x plus 4, the x plus 4s would cancel out. So that's going to give me a 2. Plus 2 times x plus 4, so this is going to give me 2x plus 8. In the denominator, 1 times x plus 4 is going to give me x plus 4. 3 over x plus 4 times x plus 4, the x plus 4s will cancel, and I'm going to get plus 3. So just to kind of simplify this a little bit, I have 2x plus 10 over x plus 7. And then we want to just always factor the numerator to see if we can cancel it out with anything. So I'll pull out a GCF of 2, and I have x plus 5 over x plus 7. So nothing can cancel here. So here is our answer. And we also need our domain restrictions. So x cannot equal. I'm going to look at my LCD. I'm going to set that to 0. So I get negative 4. I'm going to look at my denominator from my final answer and set it to 0. Negative 7. And those would be my 2 domain restrictions. Okay, and then we're going to do one more problem. And we're going to, again, look for an overall common denominator. Now notice here, these denominators are not factored. So remember the steps from when we were adding and subtracting rationals. The first step is always to factor all of your denominators. So this x squared minus 9, that's actually going to be x plus 3, x minus 3, because I can use difference of squares. So I'm just going to cross this out and rewrite it as x plus 3, x minus 3. Same thing for this one. X squared minus 9, I'm just going to make that x plus 3, x minus 3. Sorry if that looks messy. Actually, it looks really messy. Let me fix it. So 2x minus 3 plus 3x over x plus 3, x minus 3 over 3 over x plus 3 minus, so because it's minus, I'm going to change this to plus negative 4x over x plus 3, x minus 3. Okay, so that way I don't mess up with my negatives and I don't have to worry about distributing it. I'm already doing that here. So we're looking at all of our denominators. So we have an x minus 3, x plus 3, x minus 3, x plus 3, x plus 3, x minus 3. So when we look at all of them, the LCD in this case is going to be x plus 3, and x minus 3. So I can make all of these denominators into x plus 3, x minus 3. So instead of individually multiplying things, we're going to use method 2 again, and I'm going to just multiply x plus 3, x minus 3, and x plus 3, x minus 3. So top and bottom, we're getting x plus 3, x minus 3. So when I multiply 2 over x minus 3 times x plus 3, x minus 3, the x minus 3s will cancel, and I'm going to have 2x plus 6. So that's the 2 times the x plus 3. When I do this 3x over x plus 3x minus 3 times x plus 3x minus 3, both things are going to cancel. So I'm just going to have 3x. Okay, in the denominator, I'm going to multiply 3 over x plus 3 times x plus 3x minus 3. The x plus 3's will cancel out, so I'm going to have a 3 times x minus 3. So this will be 3x minus 9. And then the negative 4x over x plus 3x minus 3 times this x plus 3x minus 3. They'll all cancel out, and I'll just have this minus 4x. So now I have to combine like terms. So 5x plus 6 over negative x minus 9. And we can't factor the numerator, but I always say that you don't want your x term to be negative. So I'm going to pull out a GCF because there's always a GCF of a negative 1 if your x or x squared or whatever your highest degree is a negative. So I'll pull out that negative, and then I have x plus 9 here. So nothing can cancel out, so this would be my final answer. And then for my domain restrictions, x cannot equal, I'm going to set the LCD equal to 0, so x can't be negative 3 or 3. And I'm going to set the denominator of my answer equal to 0, so x can also not equal negative 9. Okay, so if you want to use, like I said, method 1, please use method 1. If you want to use method 2, but actually show the multiplication, how you're distributing the x plus 3x minus 3 to each one, like I did in that first example, do whatever makes sense for you. Okay, and then now you guys are going to try these 4 problems. So you have 2 that don't have any addition or subtraction going on where you need common denominators, and then 2 that do. Okay, make sure that you simplify each one and identify your domain restrictions.